Good morning. Today we're going to be working with quadratic inequalities. To start that with the warm-up, we're going to be doing just a quadratic equation to kind of remind you of that process. First off, when we have on a quadratic equation both an x and an x squared, that tells us that we're not able to simply isolate x to solve. So we need to get everything to one side equaling 0. So what I'm going to do is I'm going to take away this x. I'm going to take away this 5. So I have 0 equals x squared minus 3x minus 4. So my two options to solve this are factoring and using zero product property and the quadratic formula. Either of those are acceptable. If you need it, quadratic formula, negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. I'm going to go ahead and do factoring because it feels like I haven't done that for a little while. And there is a shorter way to do this, but I'm going to go through the process that works every time for those of you who struggle with this a little bit. If you're still struggling with solving quadratics, you can also go back to the AA5b-2 video. That has a little bit more in-depth stuff on solving those quadratics. So I'm going to start by making the box and the diamond. And of course there are other ways to do this, but this is the one we generally stick with here. I take my first term and my last term in these two boxes, and I take those and multiply them and put them on the top. So that is negative 4x squared. I'm going to take my middle term, negative 3x, and I'm going to put it on the bottom. So what I'm looking for my side numbers are two numbers that multiply to give me negative 4 and add together to give me negative 3. So the process there is simply factoring 4. 1 and 4, 2 and 2. Once I've done that, I also want to check on my negatives. The top number is negative, so I have something times something equals a negative, which means one of those numbers is going to be negative, the other one's going to be positive. On the bottom, I have a negative, which means if they add together to give me a negative, that tells me that the bigger number is going to be my negative. So if I look at each of those pairs, 1 and negative 4, 2 and negative 2, the pair that I'm looking for is going to be 1x and negative 4x. Then I put those into the remaining boxes, doesn't matter which, and I need to look at the various rows or columns. So I have x squared and negative 4x, and I'm looking for a greatest common factor. What can I divide out of both of those to come out here? And there's no number other than 1 that would work, but they both have an x. So I'm going to take out an x, and then I figure out what times x is going to give me x squared. That is also x. What times x is going to give me 1x. So that is 1. And then x times negative 4 is going to give me negative 4x. And then I always want to double check that this number, negative 4 times 1, is going to give me this number. So, and it does. So my factored form is 0 equals x minus 4 times x plus 1. So my two factors multiplying together to equal 0, this is where I'm going to use the zero product property. And you can use either quadratic formula, or the zero product property to solve. It's good to be comfortable with both of them for a lot of general purposes, but being comfortable with both of them is best. So the zero product property tells us if we multiply two factors together and they equal 0, then at least one of them has to be 0. So we set x minus 4 equal to 0, that's one of our factors, and x plus 1 equal to 0. Add 4, so one of our values is x equals 4. Subtract 4, so x equals, that was 1, x minus 1. X plus 1, we subtract 1 from both sides. I said 4, my apologies. Anyway, my two values here, x equals 4 and x equals negative 1. Now if I look back at my original equation, some of the confusion back in past sections was concerning whether you needed to solve for y or you didn't. In this case, my original problem has no y's in it, so I only need the x's. In a system of equations that does have y, you need to solve for y. So that's solving a quadratic equation. We forgot 4 and negative. What we're going to be working with now is solving a quadratic inequality. So where instead of having an equal sign, I have a less than sign. What I'm going to do is use this as though it were an equal sign to solve it. And this is the same one as I just did in the warm-up. So I'm going to say C warm-up. But I'm going to get everything to one side. So I've got 0 equals x squared minus 3x minus 4. So, and then I'm going to make the note, and this is for your notes as well, that you're going to use the zero product property or quadratic formula to solve for x. And in that process, you're not really going to worry about which direction this inequality sign is facing. Once you have the boundaries, then we'll figure that out. So from our warm-up, we know that x equals. So what I can tell you about this is that x is involved with 4 and negative 1. I don't know which way my signs are facing yet. This just gives me my boundaries. And we're going to use those on the next page. I am spelling boundaries wrong. So you solve it the same, as though it were an equation. Yes. 4. Once you have your boundaries, you're going to plot those on a number line. And this isn't always necessary, but it's particularly good for people who need the visuals. I'm going to have 0 there. 1. So negative 1 and positive 4. Because this is less than as opposed to less than or equal to, these are going to be open circles, and that's as much as I know for now. What I'm going to do is pick a number that's between those two. So the easiest one to pick right now is 0. Make sure you don't pick your boundary numbers. Make sure you pick something in between them, because your boundary numbers will be a little bit confusing. And you're going to use that to test and see if it works. So test x equals 0 in this original inequality. So I have instead of x plus 5, I have 0 plus 5 is less than 0 squared minus 2 times 0 plus 1. So for all the x's, I just plug in 0, and then I'm going to evaluate that. 0 plus 5 is just 5. I've dropped down my less than sign. 0 minus 0 plus 1, all I've got left on this side is 1. So what you want to look at then is 5 less than 1, and no, it's not. So what that tells us is this space in between our two boundaries does not work. So instead, our solution set, we're going to put this in your notes in just a moment, is going to be outside of those two boundaries. So if it's true, once you've evaluated, if it is true, then the solution is between the boundary points. And if it's not true, as it was in the case, apparently I can't spell boundaries today. If it's not true, then the solution is away from the boundaries or outside of the boundaries. And that's going to be in both directions. So just putting this on a number line to show you again. We've got the -1, we've got 0, we've got 4. 0 did not work, so we have our solutions going less than -1 and greater than 4. So in inequality form, we have x is less than -1, or, and it's an or because we can't be in both regions at the same time, x is greater than 4. That's our inequality form. In our interval form, we have parentheses. We're always going to go lowest to highest in our interval form. So parentheses, -infinity, because of this arrow going out in that direction, to -1, and that's going to be parentheses as well because the -1 is not included because that's an open circle because this was not an or equal to start with. And then the union symbol, which means or, it's just mathematics symbol for or basically. And then 4 out to infinity. Infinity will always have a parenthesis in case you were curious about that one. So checking this with a graph, basically what I have here, if I look back at my original inequality, I had x plus 5 on one side. This line right here, this line, that's my x plus 5. That's y equals x plus 5. The parabola is the other side of the inequality, which was x squared minus 2x plus 1. So this is a graph of y equals x squared, I just forgot it again, minus 2x plus 1. So those are the left and right sides of the equations, or the inequality, graphed as their own equations. So we have them crossing at x equals 4, so that's right there. And then we have them crossing as well at x equals -1. Those aren't entirely where they are supposed to be, but that's all right. Nope, it's not going to let me fix it. Anyway, and what we are looking at with those two graphs, I'm going to take those two off, is where on the graph, because our original was x plus 5 is less than x squared minus 2x plus 1. What I'm looking for is where is the line, the x plus 5, less than the parabola. And if I think about less than, I'm thinking about the y values. So where does the line go below the parabola? So right here, you guys can't see where I'm pointing. So right here, I have the parabola and I have the line. So if I'm thinking of straight vertical distances, so just straight up or down, if I am at the line and I go straight up, I have to go up to get to the parabola. So up until they cross at -1, the line is below or less than the parabola. So from that intersection point at -1 out to -infinity, my line will be below the parabola. But if I continue to the right towards positive infinity, between -1 and 4, my line, I now have to go, to get from the line to the parabola, I have to go down to get to the parabola. If I go vertically, all of these spots require that I move down. And so for the space in between -1 and 4, my line is actually above the parabola, which means that's not a solution set in there. So between -1 and 4, those values don't work for this. But once they cross again at x equals 4, once again, I'm in the situation where to get from the line to the parabola, I have to go up. And so that is where the line, once again, is below or less than the parabola. So that's when we look at a graph of the two separate ones, that's why my values are going, that's part of why my values are going outward. And a lot of people are really confused by that, but I did want to show you that's one way to look at inequalities, especially when the math on them gets a lot more complicated than just a quadratic. So to do a couple practice problems, this one is number 3 on your worksheet. I would pause for a minute and try to do the problem yourself. In this particular one, we're looking at a situation where there is no x, there's just an x squared. So I can actually isolate that x squared in this case and find my boundaries by just simple solving techniques as opposed to using the quadratic formula or factoring. So to do that, I want to get rid of this -3, so I'm going to add 3 to both sides. Got x squared is less than 9. I'm not really going to worry about that sign. I'm going to actually go ahead and take that out and put an equal sign for now, because I'm just looking for the boundaries. So if I have x squared equals 9, I am going to square root both sides to get rid of it. So I've got x equals plus or minus 3. So that's the part that people often forget. This is because if I have x squared equals 9, 3 squared is equal to 9, and -3 squared is also equal to 9. So when you are taking the square root of both sides in order to solve for an x squared, then you are looking at a positive and negative value. So if I look back at my notes and where I'm supposed to go from there, I'm going to plot that on a number line. I've got 0, -3, and +3. Because of this symbol right here not having an or equal to, my solution is going to have open circles at negative and +3. Then I'm going to test a point between them. I'm going to go ahead and test 0 again. You don't need to write this test x equals 0 or whatever, but it can be helpful for a lot of people. So instead of x squared, I'm going to write 0 squared minus 3 is less than 6. So 0 squared is just 0, so all I'm left with on this side is -3 is less than 6. That one happens to be true. It is true that -3 is less than 6. So that means that my solution set is in between -3 and +3. If it wasn't true, it would be going outward. So my inequality form of this is -3 is less than x, which is less than +3. And my interval is parentheses -3 to +3. Pardon me. So those are the answers that I end up with. For another practice one, this one's number 4 on your practice worksheet. Again, I would pause, try the problem on your own. That's going to be the best way to figure out where your misunderstandings are. This is not super duper clear, so I'm going to darken that or equal to line underneath. Because we do have an x squared and an x, we need to get everything over to one side. If the x squared is over here and it's positive, I would get everything over to the left side as well, so that I don't have to deal with a negative x squared. You can always handle a negative x squared. It's just going to be easier if it's positive. So I'm going to subtract x, I'm going to subtract 7. Now the important thing here is that you note there is no just x over on this side. We just have to write it as x squared minus x, and then we can combine the 1 minus 7 to get -6, and that is greater than or equal to 0. So now that we have this quadratic equation, or it's an inequality, but this quadratic, we either want to factor it or use quadratic formula. Since I factored it the first time, I'm going to go ahead and use quadratic formula. For that, a equals 1, b equals -1, and c equals -6. So my quadratic formula, -b plus or minus the square root b squared minus 4 times a times c, all divided by 2a. So I'm going to take out all of my a values, and I'm going to plug in 1. I'm going to take out all of my b values. Note that the negative stays there, and I'm going to plug in -1. Then I'm going to take out my c, and I'm going to plug in -6. Then I'm going to evaluate everything. So I have x equals a double -1 here is going to give me +1, plus or minus square root. I'm going to take this entire part under here. Normally I just pop it into the calculator, but I'm going to show you how that's evaluated. So -1 minus 4 times 1 times -6. So -1 squared is a +1. 4 times 1 times -6 is -24. So this ends up being 1 plus 24, which is 25. So I can actually shorten my little, there we go, shorten my square root sign there, put a 25 underneath, all divided by 2. So x equals 1 plus or minus, the square root of 25 is 5, divided by 2. So I'm going to split it into the positive and the negative. So 1 minus 5, whoops, divided by 2 is -4 divided by 2, which is -2. 1 plus 5 divided by 2 is 6 divided by 2, which is 3. So those make up my 2 boundaries. And that was probably a little excessive for what work I was showing. So what I have is a number line with -2. I'm going to throw 0 in there, and 3. And then my process from here out is the same. I'm going to have closed circles on -2 and 3. And I'm going to test a point between them. Once again, easiest point to test here is going to be 0. So I'm going to go ahead and pop that in. So I have 0 squared, and this is from my original inequality, plus 1 is greater than or equal to 0 plus 7. And you always want to make sure that you're plugging this into the original and not your changed one, just in case you made any mistakes. So 0 squared is 0, so on the left side I've just got 1 is greater than or equal to 0 plus 7, which is just 7. It is not true that 1 is greater than 7, so I'm going to say not true. And instead of going inside, I'm going to go out, because it did not work. So my inequality notation, I'm going to shrink this down a little bit so I got a little bit more space, is x is less than or equal to -2, or x is greater than or equal to 3. And then my interval notation, -infinity up to -2, and I'm going to use a bracket instead because it's a closed circle. Union symbol, bracket at 3, out to infinity, and there's my answer for that one. One of the checks for the check for understanding at the top of your worksheets caused a fair amount of confusion in class, so I wanted to make sure to go over it. On our first problem that we did, we had this inequality with the sign facing that way, and our solutions went out to infinity in both directions instead of between them. If, however, we flip that sign around, what happens is that our solutions are going to flip around too. So instead of being outside, we're going to be inside those two values. So the solution is between now. Instead of out. in a situation, this is a separate situation. If we have no boundaries, so in a problem like if this is x squared equals -2, I know there's nothing I can put in for x that's gonna make it -2. It's always going to be positive. So if we're solving this the same way that we would solve an equation, we would say that's a no solution situation. The problem with that is that this can bring up different situations. So on part A, it says pick any 3 numbers and test them in the original inequality. So it's referring to this one right here. So if I pick -5, and I put -5 squared is greater than -2, I get 25 is greater than -2. And that is true. I'm going to try 0. So 0 squared is greater than -2. 0 is greater than -2. That is also true. And to pick another one, I'm going to do a +5. And this can be any number. I'm just using a very different, I want a positive, a 0, and a negative. 5 squared gives us 25, which is also greater than -2. So there's pretty much nothing that I can put into that particular equation that won't work, or inequality, I should say. So what we want to look at here is why does this happen this way? So if I sketch the system, y equals x squared and y equals -2, I have a parabola. I'm going to put the parabola in red. That's just going to be at 0, 0, and then the line y equals -2 down here. It's not very precise. And so what we see here is a parabola that is clearly above the line, which means it's greater than the line. So when we look at the solution to the inequality x squared is greater than -2, that is always true. Always true, so x can be any real number. So that's excluding imaginary numbers. Now, if I flip the sign around, I have x is less than -2. There is no number that I can put in that would make this, that would have this parabola dipping below this line. It's always going to be above it. So if I flip that sign around, this one is never true. And so we have no solution. So when you end up in a place where you can't find boundary points like this, then you have to determine if that's an always true situation or a never true situation. So be very careful about that when you end up with your x squared equaling a negative. You have to check and see if that's always or never true. So that is my part for the 5b-2 solving quadratic inequalities. There's a practice worksheet linked on the calendar, and we will move on next time to radical inequalities. Have a good day. Whoops.